We will be discussing the problem in Pytle's book at page 198, number 4.92. Compute the tension in the cable beam when a 165-pound man stands 5 feet off the ground, as shown. The weight of the stepladder and friction may be neglected. First, let us identify the given and the required in the problem. The problem stated that there is a 165-pound man in a ladder, and we are required to find the tension in the cable beam. Then, let us make the free body diagram. Let us examine the free body diagram. As we can see, we can only solve for the tension in cable CD if we divide the diagram. And since we have an unknown force, we are to solve them first. Examining the forces, we already solved them through the free body diagram that we can see. We can see in the free body diagram, we do not know the distance of the man at the x-axis in respect with point A or point E, so we are to establish a relationship so that we can solve for the distance of the man. As we can see, there is a right triangle that we can use. So let us use that triangle. First, let us make the bigger triangle, which has a longer leg of 7.5 feet and a shorter leg of 2 feet. Then let us make the similar triangle, which has a longer leg of 5 feet and a shorter leg of x, since we do not know its distance. We can either use the tangent or the cotangent of the angle for us to be able to solve for the relationship. In this video I used a tangent. In the relationship, the value of x will be 1.3 feet. Now that we know the distance of the man from point A or E, we can now use a moment equation. As we can see that we cannot solve this problem through force equation since we only have one force equation, which is respect with the y-axis. Now, let us use the moment equation. Like any problem, we always choose which moment center we are going to use. In this video, I used point E as the moment center. But we can also use point A and C, in which it will yield the same answer. You can also choose B or D. That would make the problem more complicated, since you'll be needing to solve for the distance of point B or D with respect to point A and E, and the simplest moment center would be A, since when we were able to solve for force B, we can already solve for the tension at cable CD without considering the force exerted by the weight of the man. Now let us establish the moment equation. We always use the convention counterclockwise positive, clockwise negative. After we get this equation we already solved for F sub A, we can already stop here and solve for the tension. We will not be solving for the tension yet. For us to fully understand that point A is the best choice of moment center. If we used point A, we won't be able to solve for F sub b, so let us solve for F sub b using force equation, since F sub a is already known. This will be our established force equation. Now solving the equation, we'll be able to get this value for F sub b now. Let us solve for the tension. First, we need to divide the system, since the tension in the problem is an internal force. Cutting it perpendicular to point C, we get this free body diagram. Now, let's solve for the tension using the moment equation with respect to C, which will give us 36.7 pounds.